8.4 says I can use the combined gas law to solve problems. So let's look at a couple of these slides. Alright, first of all, we need to stop and write down our steps to solve our gas law problems. And this is also going to include our ideal gas law that we're going to get to later. So the first thing you always have to do is read your problem, underline and circle all of your information. Now you're going to need to label your underlined and circled info with appropriate variables, with pressure, volume, temperature, moles, that kind of thing. Then you're going to determine the formula that's needed based on what you've labeled. Now you got to check your units and make any conversions that are necessary. Always, always, always make sure that that temperature is in Kelvin. This is extremely important. It has to be in Kelvin before you use your formulas. Now if you're using combined gas law, P1 V1 over T1, you're going to make a table. If you're using the ideal gas law, P equals nRT, you need to determine your R value. Then you're going to rearrange your formula and you're going to solve your problem. Okay, make sure all your units are going to cancel and make sure your answer has the correct unit. So here's the combined gas law. P1 V1 over T1 equals P2 times V2 times T2. Now this one can be important when you're looking at changes in pressure, volume, and temperature and how that's going to affect those other variables. Like for example, if you want to go scuba diving, you know, you've got a certain volume of oxygen in that tank, and of course as you scuba dive, you get deeper into the ocean, the temperature and the pressure is going to change the deeper you get. So you need to make sure that your volume is not going to change too much. You need to make sure you have enough oxygen. Just the same way you would go up in an airplane, you know, and if you were going to skydive out of that, you would need to make sure that you took into account all the pressure, volume, and temperature changes. So let's look at a couple of examples. So here's our first example. If 1 liter of a gas at standard temperature and pressure is compressed to 473 milliliters, what is the new pressure of the gas in ATM? Alright, so we read, we circled, we underlined. Liters here tells me that I have a volume. Standard temperature, I'm going to remember, is 273 Kelvin. That comes from your reference packet. Standard pressure, if we want ATMs, we're going to need 1 ATM. And that's our pressure. And 473 milliliters is also going to be a volume. Now new pressure is what we're trying to find, and we want that in ATMs. So we can see that we would use P1 V1 over T1 because we have 2 volumes and 2 pressures here. Now the temperature we'll talk about in just a minute. So now let's start putting these variables together. Now you have to make sure you get the right volumes with the right temperature with the right pressure. So in this case, we're going to call 1 liter V1. And that 1 liter of gas is at a standard pressure, 1 ATM. It's also at standard temperature. So those 3 variables go together. Now P2 is what we're trying to find. V2 is our 473 milliliters, and they don't say anything else about temperature, so what we can do is assume that temperature stays constant. Now, got a couple of things we have to do here. We have to have our volume in the same unit. So the easiest thing to do here is just move your decimal point, and I'll do this in a different color, move your decimal point 3 places, so that's 0.473 liters. Now what we want to do is to look at our formula, and if we notice that our temperature is constant, then all we have to do is cross out that temperature, and we do not have to use it in our problem. What this does is it makes our formula become P1 times V1 equals P2 times V2. Now we can plug our numbers in here. So P1 is 1, V1 is 1, P2 is X, we don't know, we're looking for that, okay, and our V2 is 0.473. 4.73. So now we're going to do our math and solve for x. So x is going to equal 2.11 ATM. Now let's make sure this makes sense. Our volume is going from 1 to 0.473. It's decreasing. All right, so if my volume is decreasing, then my pressure must increase, and that's exactly what happened. The volume went from 1 to about 0.5, and the pressure went from 1 to about 2. So this answer looks like a good answer. Let's try another example. The temperature inside my refrigerator is about 40 degrees Celsius. If I place a balloon in my fridge that initially has a temperature of 220 degrees Celsius and a volume of 0.5 liters, what will be the volume if it is fully cooled by my refrigerator? Alright, so degrees Celsius is a temperature. Got another one here. Liters is a volume. We're looking for volume. So I know that my formula is going to be P1 V1 over T1 equals P2 V2 over T2. Alright, now they don't say anything about pressure, and if we're talking about the inside of a refrigerator, we can assume that pressure stays constant. And if that happens, we can cross it out of our formula. So let's look at V1 and V2. The volume that we start with is 0.5 liters. Now be careful here because this volume does start at 220 degrees Celsius. It's a hot balloon. Now because this is in Celsius, I have to add 273 to that and get my Kelvin temperature before I go on. So that is going to be 493 Kelvin. Now V2 is what I'm looking for after it cools. Now the temperature it's going to cool to is 40 degrees Celsius. So again, I am going to change that to Kelvin, and I get 313 Kelvin. Now, temperature is decreasing, so what should happen to the volume? It should also decrease. So let's do our math and check that out. So V1 is 0.5 divided by T1, which is 493. That's going to equal our X over our second temperature, which is 313. So now we're going to cross multiply these. So we get 493 times X equals 0.5 times 313. So we're going to solve for X here, and X ends up being 0.317 liters. So if X is 0.317 liters, then my volume did decrease. So that answer makes sense. Alright, determine the pressure change. We're just going to say determine the pressure before we can do pressure change. That's what we're looking for. At a constant volume, which is going to let me cross out volume, of a gas at 1 ATM is heated from 20 degrees Celsius to 30 degrees Celsius. So ATM tells me I have a pressure. I'm trying to find pressure. I have a temperature and a temperature. Alright, so our volume of gas is at 1 ATM, and that starts at a temperature of 20 degrees Celsius, so we have to add our 273, so we get 293 Kelvin. We're looking for our second pressure if we go to 30 degrees Celsius. So again, we have to change that to Kelvin, so we get 303 Kelvin as our second temperature. Alright, so our formula started out P1 V1 over T1 equals P2 V2 over T2. So because my volume is constant, I can cross that out. So my P1 is 1. Well, I don't need the parentheses. Alright, so P1 is 1 over 293 Kelvin. That's going to equal X over 303 Kelvin. Now, temperature is increasing, so what should the pressure do? Pressure should increase. Now this is not a huge temperature increase. It's only 10 degrees. So let's do our math. So we cross multiply. So 293 times x equals 303 times 1. So x is going to equal 1.03 ATM. So we did have an increase in our pressure just like we predicted. Not a huge one, again, because this is a very small temperature increase. Now let's look at an example where nothing is constant. We initially have a gas at a pressure of 12 ATM, a volume of 23 liters, and a temperature of 200 Kelvin. I raise the pressure to 14 ATM, increase the temperature to 300 Kelvin. What is the new volume? So ATM is pressure, liters is volume, Kelvin is temperature. We have another ATM, pressure, another Kelvin, temperature. We're looking for volume. So we know that P1, V1, T1 is going to be our formula. So let's make sure we get our variables together. So 12 atmospheres of pressure has a volume of 23 liters and a temperature of 200 Kelvin. Now it's already in Kelvin, so I can leave it. I'm going to increase my pressure to 14 atmospheres. I'm looking for a new volume if my temperature is also increased to 300 Kelvin. Now this one, it's a little bit harder to predict because we have a pressure increase, which means the volume should decrease. But look at this, we have a huge temperature increase, which means the volume should increase. So this one is a little bit more difficult to predict. Alright, we may not be able to predict it. Alright, so let's fill our variables in. So P1 is 12 times V1 is 23 over T1 is 200. So notice that this column is all on the left-hand side of the fraction, and this column is all on the right-hand side. So be careful and make sure you put your variables in the right place. Alright, so 14 is P2, X is V2, and then T2 is 300. Now again, we're going to cross multiply here. Okay, so when you cross multiply, you're going to get 12 times 23 times 300 equals 200 times 14 times x. So we're going to want to solve for x here. Alright, and you get an x equal to 29.6 liters. So again, volume increase because the temperature increase was greater than the pressure increase. Okay, so this is your answer.